Hi everyone. So we have been studying about antenna arrays. In the last lecture we studied about antenna array. Now we are going to see the radiation pattern of antenna arrays. So two element antenna array we have seen. We are having two antennas. Because of that, at a distance, at far field, at point P, we find the electric field intensity. So for how you write down the expression, that also we have seen. Now we need to draw the radiation pattern. So if you have already studied antenna, then you would know what do you mean by radiation pattern. What is the radiation pattern? Here we draw electric field with respect to theta and phi. When we draw with respect to theta, we keep phi equals to 90 degree and we call it E-plane pattern. And when we draw with respect to phi, we keep theta equals to 90 degree and we call it H-plane pattern. Right? All this we have seen for a normal antenna. Now we are having? We are having antenna array. So in the antenna array, what is our E field? This is our E field. Electric field due to a single element at origin. Electric field due to a imaginary single element at origin into array factor. So how will your radiation pattern will look like for antenna array? This is the electric field at far field point P because of the antenna array, which is equals to electric field due to a imaginary single component, or you can say due to a single imaginary antenna at origin into array factor. So what I need to do, I need to make the radiation pattern of ESO, electric field due to single element at origin, into radiation pattern of array factor. So I will draw the radiation pattern of both of them and then I will multiply both of the radiation patterns. Okay. What we are going to do is that we are going to draw the radiation pattern of ESO and we are going to draw the radiation pattern of array factor and then we are going to multiply them. So in the examination till this date, they always ask the radiation pattern of array factor only. They never, I guess in one examination, or I guess never they asked the complete radiation pattern, or only once it has been asked for the complete radiation pattern. Mostly they ask the radiation pattern of array factor. Do you know how to draw the radiation pattern of ESO? Yes, certainly you know how to draw the radiation pattern of ESO that you already know. Like due to one antenna at point P, can you write down the electric field expression? Yes. And due to one antenna, can you draw the radiation pattern? If antenna is placed like this, and let's just say this is Hertzian dipole antenna. If antenna is placed like this and it is Hertzian dipole antenna, then how will the radiation pattern look like? This is how it will look like. If it is a half wavelength antenna and it is placed like this, then how will the radiation pattern look like? This is how the radiation pattern look like. What do you do? You find the normalized value of E. Then it is a function of theta. And then with respect to that, you draw it. For this one, what was the normalized value of E? Cos pi by 2 cos theta. And for divided by sin theta as well. And for this one, what was the normalized value of E? Sin theta. So in the direction of antenna axis, or along the direction of antenna, there is nulls. Along the direction of antenna, you will never get any radiation. This is the thing. No matter what kind of antenna it is, whether it is half wave, whether it is full wave, whether it is 3 lambda by 2, whether it is 1.5 lambda, 1.7 lambda, in the direction of antenna, you will never have any radiation. Do you agree to this point? Yes. And in most of the antennas, at the perpendicular direction to the antenna, you get the maximum radiation. That means here you get the maximum radiation, here you get the maximum radiation in most of the antennas, but not in all the antennas. We saw for 3 lambda by 2 it was different. We saw for 1.25 lambda it was different. So those are different. Here you are having multiple lobes. So if those kind of radiation pattern are coming, then you need to make it on your own. But do you remember the radiation pattern of Hertzian dipole? Let's just say this is how my antenna is placed. So this was the radiation pattern for Hertzian dipole, right? Similarly, this was for Hertzian dipole. Similarly, this was for lambda by 4 as well. This was for lambda by 2 as well. And this was for lambda as well, if you remember. Although the width were different. Like for Hertzian dipole, this was the width. For lambda by 4, the width will be lesser. For lambda by 2, width will be lesser. And for lambda, this distance will also be increased. But the pattern was same. Pattern was like this only, if you remember it. For Hertzian, lambda by 4, lambda by 2 and lambda. You can go back to your notes. You will realize that for all of them, the pattern was same. So mostly the thing is, in antenna array, if they are asking the complete radiation pattern, then there is a very high chance that the antenna that they are going to use, these two antennas that they are going to use, these will be either Hertzian or lambda by 4 or lambda by 2 or lambda. Very, very high chances are there. Very, very high chances. This is what I am saying. Okay. If you see the book of Balanis, so there only these examples are taken. Where if you take this antenna, if you take single element at origin, then quickly you can draw the radiation pattern. Because here you don't need to think that what will be the radiation pattern for Hertzian, for lambda by 4, for lambda by 2 and lambda. Okay. So in most of the examples you will find this thing only. But in the examination, in gate examination, they have only asked the radiation pattern of array vector. Okay, let's start now. So this I already know how to draw the radiation pattern of a single element at origin. This I need to understand. So I know how to write down the array factor. If I know how to write down the array factor, can I find the position of nulls for the array factor? For array factor, can I find the position of nulls? Yes. What I will do? My phase difference should be equals to what? My phase difference should be equals to 2n plus 1 pi. This we have already seen in the last lecture. Can I find the position of a maximum radiation? Yes. What should be my phase equals to? 2n pi. And can I find the position of half power? Yes. My phase difference should be equals to 2n plus 1 pi. 2n plus 1 pi by 2. That means odd multiple of pi by 2, even multiple of pi, and odd multiple of pi. Where n can vary from n to 0 to plus minus 1, plus minus 2, and so on. So yes or no. Okay. So let's start with the question. We need to draw the radiation pattern of this setup. So for this setup, first write down the electric field. Electric field at point P. Point P, it might happen that it is not mentioned. And certainly if they are asking the radiation pattern, they will not mention the point P. So you need to assume point P by your own, anywhere. This is the point P. This is how your antenna are placed. So the imaginary antenna that I am gonna assume at origin. The imaginary antenna that I am gonna assume at origin. This is my imaginary antenna that I am gonna assume at my origin. That will be placed like this. And which angle I am more concerned about? Angle between the axis of antenna, and AR gap. So this is the angle that I am concerned about. And what is this angle? 90 minus theta. Because this angle I take as polar angle, which is equals to theta only. So two cases are there. You are not able to see it. Just 1 second. Two cases are there. Yeah. So these are the question. The first one is, here the alpha value is 0. The distance between both of the antenna, this is the distance d. The distance between both of the antenna is lambda by 2. The distance is lambda by 2. So what is this distance? Lambda by 4. What is this distance? Lambda by 4. Right? The total distance is lambda by 2. And you need to consider Hertzian dipole antenna. What do you need to consider? Hertzian dipole antenna. So at the origin, my imaginary antenna will be Hertzian dipole antenna only. So what will be the radiation pattern? If you already know, the radiation pattern will look something like this. Right? Because this is how my antenna is placed. So radiation pattern will be upward. If this is how the antenna would be placed, so radiation pattern will be like this. Along this side. Along this side. And if this is how antenna is placed, then radiation pattern would be along upward and downward. Although you don't need to calculate it, but still I am calculating it. Because just as you look at the antenna, you can draw its radiation pattern. But let's just calculate it. So what will be your ESO? Or total electric field if I write down for first one. For first case, I am writing down the total electric field. For first case, total electric field. What that would be? I naught dl cos theta. Why not sin theta? Because this is how antenna is placed. So sin 90 minus theta is cos theta. So this we have seen a lot of times. So I dl sin theta cos theta upon 4 pi r into j beta e to the power minus j beta r AR cap. So what is this? This is your ESO. Right? And can you draw the radiation pattern of ESO? Yes. How will you draw? So for ESO, what is the normalized value? Although you don't need to do all these things because you have already done it. When we are studying normal antenna, we have already done all these kind of things. And where do we draw the radiation pattern? We only care about E plane. And what do you mean by E plane? E plane means phi equals to, this is the E plane I am drawing, phi equals to 90 degree. So I am only gonna draw the E plane pattern. So here theta is equals to 0 degree, here it is 90 degree, here it is 180 degree, and here it is 90 degree again. So if you put cos 0, what you are getting? 1. If you put cos 90, what you are getting? 0. So that means what is the position of maxima? And if you put cos 180, what you are getting? -1. But what do we take here? Here we take always the magnitude. So here you are getting +1 only. So at 180 degree, you are getting, sorry, at 0 degree you are getting 1. At 180 degree you are getting 1. At 90 degree you are getting 0. At 45 degree, what you will get? This is here your 45 degrees. This is here your 45 degrees. So at 45 degree, what you are getting? 1 by under root 2. At here as well, you are getting 1 by under root 2. At 135 degree as well, you will get 1 by under root 2. And here as well, you will get 1 by under root 2. So what kind of pattern you will get? You already know. This kind of pattern we get. Right? So this we have already seen. So it is not that tough for us. And how my antenna is placed, that also I can make. This is how my antenna is placed. We have drawn a lot of patterns, so I don't think it would be that tough for you. It should be very easy. And till this point, you should be comfortable with these kind of patterns. Okay, so yeah. What is the maximum value? We were getting 1. These were 1. Okay, now let's write down the array factor. So how will you write down the array factor? So e to the power. What is the phase difference? 0 degree. So alpha is 0 here. Here also it is already 0. So e to the power j0, e to the power j beta. Then from here to this point, d. What is d here? D is lambda by 4. The distance d1. This distance if I call d1 here, and this distance if I call d2. So in this case, d1 is equals to d2 is equals to lambda by 4, because total distance is lambda by 2. So it would be lambda by 4. So here lambda by 4 is the distance. And then from the origin towards the antenna, this vector and this is your AR vector. What is the angle between them? Theta. So what will be the answer? Here what you will write down? Cos theta. Say yes or no. Plus for the next one, e to the power j0, e to the power j beta. What is the distance? Lambda by 4. And what is your AR gap? This is your AR gap. So from the origin towards the antenna, this is the vector. From the origin towards the antenna, this is the vector. So what is the angle? 180 minus theta. The angle is 180 minus theta. So what you are going to write down here? Cos 180 minus theta. That will be minus cos theta. Cos 180 minus theta will be minus cos theta. These examples we have already seen. So it should not be that difficult for you. So this is your array factor. This is your array factor. So if I write down array factor again, here if I write down array factor. So what I am getting as array factor? What is beta lambda? Beta into lambda. That is equals to 2 pi. Because what is beta? Beta is 2 pi by lambda. So beta into lambda is 2 pi. Beta into lambda is 2 pi. So what I can write down? E to the power j pi by 2 cos theta. Because beta into lambda is 2 pi. 2 pi by 4 is pi by 2. Pi by 2 cos theta plus e to the power minus j by 2 cos theta. So what is the phase difference? Phase difference from here to here you can subtract, or from here to here also you can subtract. I am subtracting from positive to negative. So phase difference is pi cos theta. What is the phase difference? That is pi cos theta. Now what do I need to find? I need to find the, let's write down array factor here again. Array factor here is, here you need to take a special care of the calculation. Let me check it again if I am doing it correctly. Beta lambda by 4, 2 pi, pi by 2, pi by 2, and here also lambda by 4 will also come. Right, I forgot. Lambda by 4. So here pi by 2 cos theta, here also. Okay, it is fine. And my phase difference is coming out to be pi cos theta. Now if I find the position of maxima, so what that would be? That my phase difference should be equals to 2n pi. If I find the position of maxima, that means my phase difference should be equals to 2n pi, that is equals to pi cos theta. So what is the value of cos theta you are getting? 2n. Now what all value you can put? N equals to 0 you can put, n equals to 1 you can put, n equals to minus 1 you can put. But if you put n equals to 0, what you are getting? Cos theta equals to 0. And from here, theta is equals to pi by 2. This is acceptable. Now you will say that, sir, it would be 3 pi by 2 as well. But what is the range of theta we need to take? The range of theta always goes from 0 to 0 degree to 180 degree, both included. So theta equals to pi by 2. If I take n equals to 1, what I am getting? Cos theta equals to minus 2, which is not possible because the range of cos theta is from minus 1 to 1. And if you put n equals to minus 1, here only. If you put n equals to -1, then cos theta is, if I put n equals to 1 here, cos theta is equals to 2, not -2, sorry. If I put n equals to 1, cos theta is equals to 2. If I put n equals to -1, then it would be -2. This is also not possible. So what is the position of maxima? This is the position of maxima. This is the position of maxima. Here you are getting the maximum. Let's see the second point, that is nulls. Let's see the nulls. So phi equals to, what should be phi equals to? Phi equals to 2n plus 1 pi for the nulls. And that should be equals to pi cos theta. So cos theta is equals to 2n plus 1. Can I put n equals to 0? Certainly I can put. So if I put n equals to 0, someone is calling. If I put n equals to 0, cos theta is equals to 1. So from here what we are getting? Cos theta equals to 1, where do you get? At theta equals to 0 degree. Right? At theta equals to 0 degree only you get. If I put n equals to 1, so what I am getting? Cos theta equals to 3. Not acceptable. If I put n equals to -1, cos theta equals to -1. Yeah, this is acceptable. Where you are getting? At 180 degree. Right? If you put cos theta equals to -1, sorry, if you put n equals to -1, so what you are getting? Cos theta equals to -1. That means theta equals to 180 degree. 180 degree is acceptable. Can you put n equals to +2? No, cos theta will be 5. Not acceptable. Can you put n equals to -2? No, cos theta will be -3. That is also not acceptable. So these are the position of nulls. So position of nulls we have got. These are the nulls. Let's find the half power. Half power point. Half power. If you want to find, then you can find. Otherwise, using position of nulls and using the position of maxima as well, you can draw the pattern, right? But let's find out the position of half power as well, because these they can ask in the examination sometimes. So for the position of half power, what I need to do, that my pi cos theta, or whatever you can say, that is your phase difference, that should be equals to 2n plus 1 pi by 2. So from here what you are getting, cos theta is equals to 2n plus 1 by 2. So if n is equals to 0, so cos theta is equals to 1 by 2, and that is equals to theta equals to 60 degree, right? And if n equals to 1, not acceptable, because if you put n equals to 1, what you are getting? 3 by 2, not acceptable. If you put n equals to -1, what you are getting? Cos theta equals to -1 by 2. That means theta is equals to 120 degree. Theta equals to 120 degree. This is what you are getting. So theta equals to 60 degree and 120 degree. These are your half power points. So what did you understand? If I make the pattern here, I have already made the pattern actually, but let's make the pattern of array factor now. This is what I am making. I am making for array factor. This I am making for array factor. Okay. So what is the position of maxima? Theta equals to pi by 2. This is your z. This is your y. Yeah. Okay. And from now onwards, I will not show z and y. From now onwards, I will just show the angle. So theta equals to 0 degree. Theta equals to 90 degree. Theta equals to 180 degree. And this is also your theta equals to 90 degree. So at 90 degree, you are having the maxima. So at 90 degree, magnitude is 1. At 0 degree and 180 degree, you are having minima. So this is the point of 0 degree, 0 you are having. This is the point of 180 degree, again 0 you are having. At 60 degree, you are having the half power. So at 60 degree, you are having E naught by 1 by under root 2. And here also 1 by under root 2. So whatever the pattern you get here, something like this, the same pattern you will be getting here as well. Something like this. So this is the pattern. And how your antenna is placed? This is how the antenna is placed. Now, for the radiation pattern of single element, this was your single element. For the radiation of pattern of single element, there could be no lobes in the direction of element. What I mean to say is that if my antenna is placed like this, so you can never get a lobe here. You will get a lobe upward or downward. But if I am finding array factor has nothing to do with the antenna. Array factor has nothing to do with the antenna. In our geometry, how the antennas are placed. This is how the antennas are placed in our geometry, right? This is the imaginary one. This is the imaginary one. And actually, this is how the antennas are placed. So in the direction of antenna as well, you can get the radiation pattern. Are you getting this point or not? Here, this is the direction of antenna. This is how the antennas are placed. And in the direction of antenna as well, you are getting the radiation pattern. When you talk about what? When you talk about the array factor. So array factor has nothing to do with the property of antenna. This is just a quantity. Are you getting this point? So if someday I say that the array factor is having its maximum radiation at theta equals to 90 degree. So there is no doubt about that. At theta equals to 90 degree, it can have its maximum radiation even though your antenna is lying on y-axis only. This is the y-axis. Even though my antenna is lying on y-axis, and it can have the maximum radiation on y-axis as well. But if I say that my antenna is lying on y-axis, it could be any antenna. So for the antenna, not for the array factor, for the antenna where you will have the maximum radiation. One thing for sure, for the antenna on x-axis, I will never have the radiation. For antenna. Again, I am repeating the thing. Array factor can have the maximum radiation anywhere. Array factor can have maximum radiation anywhere. But your antenna cannot have the maximum radiation where it is placed. If it is placed on y-axis, so on y-axis, it will never have any radiation. Forget about the maximum radiation. On y-axis, it will never have any radiation. If you remember the radiation pattern of 3/2, it was like this. It was like this. Right? So this is where antenna is placed. Antenna is placed right in the middle. So in the middle, you will never get any radiation pattern. This was the position of null. Theta equals to 0 degree and theta equals to 180 degree. 100% this will be the position of null. There is no chance. But if I say that I am making the radiation pattern for antenna array. So for antenna array, anywhere you can get the maxima, anywhere you can get any lobe. So for antenna array, you should not be getting confused that, sir, okay, how I am getting radiation in that direction or this direction. At that point, you don't need to think. But if you are making the radiation pattern of ESO, then certainly this is how the lobes will be going. Certainly in this direction, you will never get any lobe. Okay? Is this point clear? When I was a student, I used to have this doubt that how array factor is having any radiation. Like in array factor, why we are having radiation in this direction? We are having array factor is just a quantity. It has nothing to do with the antenna. So for array factor, you can have radiation in any direction. Right? So array factor is just defining a particular quantity. Now what we need to do? We need to multiply both of the antenna pattern or antenna radiation. So this was the radiation for ESO. Right? This was the radiation for ESO. This was the radiation for ESO. And this is the radiation for array factor. Here I have drawn. Now if I am multiplying both of them, that means I need to take the common area. This area is multiplied with this area. What we need to take? Common area, no? So now if I take the common area, what will be the common area? This will be the common area. This will be the common area. Or let me make it better. Here I can show it like this. This will be the common area. Here this will be the common area. And this will be the common area. This will be the common area. So this was the radiation pattern for array factor. And I can make the radiation pattern for ESO as well. Here only I am making the radiation pattern for ESO. This is your theta equals to 0 degree. This is your 90 degree. This is 180 degree. And this is 90 degree. This was for SEO, whatever we write down. Electric field due to single element at origin. So this was for SEO. Okay. And now this is both combined. This is the multiplication of array factor and electric field due to single element. This is the multiplication. And what is the result of multiplication? That I am showing here. What is the result of? So this is the final pattern of your complete antenna array. So this I will say that this is the radiation pattern of antenna array. So there are 3 steps involved: ESO, array factor, and the multiplication. So when you do the multiplication, what you are gonna get? Here there will be one lobe. Here also there will be one lobe. Here also there is one lobe. And here also there is one lobe. So this is the pattern we are getting. Very famous, very standard example. Okay, it is very, very famous. So this is the final answer. But in the examination, mostly like most of the times they have asked the radiation pattern of array factor. But I don't know why they focus much on this. They focus much on the array factor, radiation pattern of array factor, not on the final one. Like final one is more interesting, I guess, because this and this you need to multiply as well. So this is how you will be multiplying. Say yes or no. Fine. Okay, then let's move to the second part. There are two parts. Alpha is equals to pi by 2 now, and d is equals to lambda by 4. Now you need to consider full wave dipole antenna. That means the length is equals to lambda. Okay, length is equals to lambda. So let's start. Again, the same thing is there. I will assume a antenna at the origin, and I will write down the expression. So what will be the expression now? So B part. So first thing is, first I will find the f theta, because I know for full wave I need to write down the f theta, because this is a linear dipole antenna now. So for that we need to write down f theta. What is f theta? Cos beta L by 2 cos theta minus cos beta L by 2 divided by sin theta. What is beta L by 2? Beta is 2 pi by lambda, length is L by 2. So what you are getting? Pi. So cos pi cos theta. What is cos pi? Minus 1 divided by sin theta. This is your f theta. So if I know the f theta, can I directly draw the radiation pattern for ESO? Yes. Electric field due to single element at origin. Can I directly draw it? Certainly I can draw it. So first I can find the position of null. Although this I have already taught, but let's do it again. How do we find the position of null? You put f theta equals to 0 for nulls. F theta equals to 0. There is different way of plotting radiation pattern for array factor, and there is different way of plotting radiation pattern for antenna. Both are two different things. So don't forget how did you plot it for this guy. Okay, for single element, how did you plot? You find the location of nulls. If you know the nulls, then you know that between two nulls you will have a maxima. So what I will do, f theta equals to 0. So what I will get, cos pi cos theta should be equals to minus 1. And if it is equals to minus 1, what you are gonna get? So from here, pi cos theta would be equals to 2n plus 1 pi. Say yes or no, because cos theta equals to minus 1. When it could be equals to minus 1. Minus 1 at pi, then again 2n ahead. Yeah. So cos theta is equals to 2n plus 1. So from here n equals to 0 if I put. So cos theta equals to 1. That means theta equals to 0 degree. This is the position of null. And if I put n equals to minus 1, because n equals to 1 I cannot put. If I put n equals to minus 1, cos theta is equals to minus 1 and theta is equals to 180 degree. So I know the location of nulls now. In between there will be a maxima. So in between at 90 degree there will be maxima. So at theta equals to 90 degree. At what I mean to say is that at theta equals to 90 degree, what is the value of f theta? At theta equals to 90 degree. The value of f theta is theta equals to 90 degree. Cos 90 is 0. Cos 0 is 1 and this will be 2. Okay, now again guys, there is a thing that here our angle is 90 minus theta. Here I have put this expression cos beta L cos theta. At that time this is how my antenna should be placed. If my antenna is placed like this, then all this analysis is correct. But now my antenna is placed like this. My antenna is placed like this here. Are you getting this point? So all these value I have found out for this case. But I need to get for this case. So here I need to change. So here I need to put sin theta. Here I need to put cos theta, because cos 90 minus theta will be sin theta. And this will be cos theta. Right? Because the angle between the arms of antenna and AR cap is 90 minus theta. Although if I make the radiation pattern for this guy, that will look something like this. From this expression you get to know. Now if I need to make it for this one, then what I need to do? I just need to rotate it. So if I just rotate it, then this is how the radiation pattern will look like. So in the examination, if you do this mistake, then you will realize that you have taken this antenna. because angle between the arms of antenna and AR cap is this theta, and that theta you have taken here. But our actual theta is here 90 minus theta, and because this is how my antenna is placed. So since I am like making the fair notes, so let's make it correct again. So here pi sine theta, and this will be cos theta, and let's erase it. So for position of nulls, pi sine theta should be equals to minus 1. So here pi sine theta should be equals to 2n plus 1 pi, 2n plus 1 sine theta should be equals to 2n plus 1. And if I put if I put n equals to 0, then theta value what all I am getting. If I put n equals to 0, like I hope you must have got this point, right? This should not be that difficult. What I am doing here. In the previous analysis as well, I did the same thing. Here sine theta comes, but our angle is between the arms of antenna and AR cap. Our angle is 90 minus theta. That's why it will become cos theta. Similarly, here it will become sine theta, and this will become cos theta. I hope this is clear to you. If you put n equals to 0, what you are getting? Sine theta equals to 1. And if you put n equals to minus 1, then what you are getting? Minus 1. So sine theta equals to 1, where it is? At pi by 2. And where it is? Minus 1. That's it. Sine theta equals to, if you put n equals to 0, at pi by 2 it is 1. At pi by 2 it is 1. Wait a second, there is some error, I guess. Cos pi cos theta, downward it is cos theta. So null I need to put it equals to 0. It is placed at theta equals to pi by 2 you are getting. At theta equals to pi by 2 you are getting a null. Okay, fine. Okay, so this is the only position of null, because if you put n equals to minus 1, what you are getting? Sine theta equals to minus 1. And when do you get sine theta equals to minus 1? This is the graph of sine theta. So sine theta equals to minus 1 you get at 3 pi by 2. That you don't need to take in action, because theta value will go from 0 degree to 90 degree only. Right? Because theta, really sorry, theta value will go from 0 degree to 180 degree only. So only this much range I need to put. So only one null is there, that is at theta equals to pi by 2. That's it. So one null is there at theta equals to pi by 2. So now I can make the radiation pattern. Here what is the value of theta? That is 0 degree. Here 90 degree. Here 180 degree, and here it is again 90 degree. So at 0 degree what will be the value? Let's check out the value at theta equals to 0 degree. So what f theta you are getting? So at theta equals to 0 degree, sine 0 is 0, cos 0 is 1, 1 plus 1 2, cos 0 is 1. So what you are getting? 2. Same you are getting at 180 degree as well. Same you are getting at 180 degree as well. If you talk about the magnitude, at cos 180 will be minus 1. So here if you put sine 180, that would be 0. Cos 0 is 1, 1 plus 1 is 2. 2 divided by minus 1, that would be 2. But you need to take the magnitude. So if I take the magnitude, I am getting f theta equals to 2 only. So at theta equals to 0 degree and 180 degree, 0 degree and 180 degree, mode of f theta you are getting as 2 only. Right? And one thing also you will get to know that this is the position of null. Position of null is this. This is the position of null, and this is also a position of null. So between two nulls, this is a null, this is also a null. Between two nulls, what do you get? A maxima. And same goes here as well. Between two nulls, you will get a maxima. Right? So this is how the radiation pattern will look like. The important point to note here is that what is the maximum value? 2. Here what is the maximum value? 2. So this was the different thing with lambda. Lambda by 2, lambda by 4, all ends with the maximum value of 1. Even Hertzian dipole also ends with the maximum value of 1. Here you can check. It is also ends with the maximum value of 1. But lambda antenna, lambda dipole antenna or full wave dipole antenna ends with the maximum value of 2. So this is a very important point here. A very, very important point. Because this will be used in our array factor. Now we will draw the radiation pattern of array factor. So this point will be used there. Because what we need to do, we need to multiply. Now I need to multiply this radiation pattern with something else. So now I need to know where it ends. Are you getting this point? I need to know where this radiation pattern ends. If I am knowing this thing that where it is ending, then it would be easier for me to multiply. Let's check out the radiation pattern of antenna, oh sorry, let's check out the radiation pattern of array factor now. So for array factor, so what is my array factor? Can you let me know? A to the power j. Let's get back to this diagram again. First diagram. So what is the distance now? D1 equals to D2 equals to lambda by 8. The distance is lambda by 8. Okay. And here the phase difference is pi by 2. So for if I talk about antenna 1, this is my antenna 2. So from the origin towards the antenna, right? So what I will write down, e to the power j, what is the phase? Pi by 2. Then e to the power j beta, what I need to write down? D1. So what is my D1 here? My D1 is lambda by 8. And this vector and this vector, because this is my D1 vector and this is my AR cap. What is the angle between them? Theta. So what I will write down here? Cos theta. Say yes or no? Plus, what is the phase next? Next, here the phase is 0 degree. Because this is phase shifted by pi by 2, but this is not phase shifted. So here the phase is 0 degree. Plus j beta. This vector dot product with this vector. This vector dot product with this vector. So what is the angle? 180 minus theta. So what I'm going to write down? Lambda by 8. And what is cos 180 minus theta? Minus cos theta. So this is how I'm going to write down. Right? So let's write it down now. Okay, I am not a fan of Ajay Devgan. Again I am saying it. Here I am having elaichi. Okay, I am not eating anything else. I am having lychee so that I don't cough. Because you know that I am having the problem of cough. So I don't have cough. That's why I am having the elaichi. I am not biting anything else. Okay. So don't think I am biting any pan masala or anything else. Okay, so let's not go off topic. So that is beta lambda by 8 cos theta plus this is having a phase of 0 into the power j beta lambda by 8 cos theta minus sign. What is the value of beta lambda? 2 pi, pi by 4. Pi by 4 you will get here. Pi by 4 cos theta plus e to the power minus pi by 8 cos theta. What I need to write down now? Phase difference. So from here to here you can write down, or from opposite as well you can write down. I am writing from positive to negative. So pi by 2 plus this is also pi by 4 only, no? So what you will get if you calculate the phase difference? So pi by 2 plus pi by 4 cos theta minus of minus pi by 4 cos theta. So what you will get? This is what you are getting. Or you can write down in this manner, pi by 2 into 1 plus cos theta. Okay. So if I calculate the maxima, so for maxima what is the scene? Your phi should be equals to 2n pi. So pi by 2 into 1 plus cos theta should be equals to 2n pi. So cos theta is equals to 4n minus 1. Right? 1 plus cos theta, this pi and pi get cancelled, 4n minus 1. Cos theta equals to 4n minus 1. If you put n equals to 0, what I am getting? Cos theta equals to minus 1. If you put n equals to 1, not acceptable, because 3 you will get. If you put n equals to minus 1, you will get minus 5. That is also not acceptable. So cos theta equals to minus 1. Where do you get it? At pi. So this is the position of maxima. Right? And if I find the position of nulls, what will be the position of nulls? So the position of nulls, phi should be equals to 2n plus 1 into pi. So pi by 2 into 1 plus cos theta should be equals to 2n plus 1 pi. So 4n plus 2, 4n. So for nulls, this and this will be getting cancelled. So this goes here. 4n plus 1 you will be getting. Cos theta equals to 4n plus 1. So what do you think, which value of n will be accepted? Which value of n will be accepted? Only n equals to 0 will be accepted. Right? N equals to 0, because if you put n equals to 1, 5. If you put n equals to minus 1, minus 3. Again not accepted. Right? So n equals to 0. So cos theta equals to 1. So theta equals to 0 degree. So here you are getting the null. right? Let's find half power. Half power. So this is a different kind of pattern you are going to get this time. What is the half power now? So for half power, what I need to do, my phase difference should be equals to odd multiple of pi by 2. So pi by 2 into 1 plus cos theta is equals to 2n plus 1 pi by 2. This and this get cancelled. Cos theta equals to 2n. So n value again you can put, which value you can put? N equals to 1 only you can put, or n equals to 0, sorry. N equals to 0 you can put. So for n equals to 0, what we are getting? Cos theta equals to 0 degree and theta is equals to 90 degree. Okay. So this is the position of half power. Maxima is there, null is there. This is the position of half power. Try making the pattern on your own. I will make it on the next page, but pause the video now and try making the pattern on your own. You have the position of maxima, you have the position of null, you have the position of half power as well. Try making the pattern on your own. Did you try it? Let's check out now. Okay. So this is the final diagram that I have already drawn, but let's draw the pattern for array factor. For which one we are drawing? For array factor. Theta equals to 0 degree, theta equals to 90 degree, theta equals to 180 degree. यार mic नहीं connect किया यार. We did not connect the mic and the sound would not have been that good. But now I am connecting it. So please, this is theta equals to 180 degree. This is theta equals to 90 degree. Okay. Yeah, so let's get started. So at theta equals to 0 degree, there is null. At theta equals to 90 degree, there is half power. So at 0 degree, you are getting null. At 90 degree, you are getting some value. Let's just say here the maximum value is at 180 degree, you are getting the maximum value, no? At 180 degree, you are getting the maximum value, that is at 180 degree, you are getting maximum value. So here you are getting the maximum value. If this is, let's just say alpha, then this is alpha by under root 2. And similarly here as well, alpha by under root 2. So what do you think? How will the pattern go? Like it cannot go like this. Certainly it cannot go like this. Because at one angle, if it goes like this, that means what you are saying, at 90 degree you are having this value as well and this value as well. So certainly it cannot go like this. So how it can go? It can go like this only. So kind of heart-shaped structure you get. Are you getting this point? Well, let's make it better. It would be like a circular, like this. So this heart wave structure you are going to get. Say yes or no. Is that clear? Or like, I hope some guys are not thinking that sir, we will get something like this. Again, then you are saying that at a particular angle you are getting two. Like at this angle you are getting two values. This is what you are saying. If you are saying that it is going like this. No. At one angle you get only one value. So in this case, whether you take angle here, you take angle here, or here, or here, at all the angles you are getting one values only. Okay, so it will go like this heart-shaped structure. Now the thing is, we need to multiply this function with this graph. Which graph? This graph. This is your theta equals to 0 degree. This is 90 degree. This is 180 degree and this is 90 degree again. So this was ending at 2. This was ending at 2, right? Both were ending at 2, 2. Now where this is ending? That I need to know, no? Like I will multiply this with, this is how I will multiply. If this is ending less than 2, then this is how I need to multiply. And if it is ending at exactly 2, then this is how I will multiply. So now I need to know where it is ending. This is the task for me. Are you getting this point? Right? And let's just say if this is ending at 2 and this is ending at 4, then this is how I will multiply. But let's check where it is ending. So that's why it was important that what is the maximum scenario here? What is the maximum point it goes? It goes till 2. But if it was a Hertzian dipole, then it would have gone till 1 only. In Hertzian dipole, it goes till 1 only. If it was lambda by 2, then also it would have gone till 1 only. If it was lambda by 4, then also it would have gone till 1 only. But if it is lambda, then it is going towards 2. Let's check out for this one. At theta equals to 180 degree, what is the value of array factor you are getting? So what was your array factor? Array factor was e to the power j pi by 2 plus pi by 4 cos theta plus e to the power j minus pi by 4 cos theta. So what is the magnitude of array factor at theta equals to 180 degree? At theta equals to 180 degree. What is your array factor? And certainly we are plotting magnitude only here. So I am talking about magnitude. So what is my array factor here? So theta equals to 180 degree. What this would be? Cos theta. Cos 180 minus 1. So this is pi by 2 only, no? Yeah, okay. Yeah, so cos 180 is minus 1. So what you are getting? E to the power j pi by 4. Because pi by 2 minus pi by 4 will be pi by 4. Plus e to the power j. What about this one? Cos 180 is minus 1. Minus 1 into minus 1 would be plus 1. Right? So this is what we are getting. Now what is this equals to? What is e to the power j pi by 4? Cos pi by 4 plus j sin pi by 4. Right? What is cos pi by 4? 1 by under root 2 plus j 1 by under root 2. And double of that. What will be double of this? Just multiply by 2. What will be the double of this? Under root 2 into 1 plus j. So what you are getting? Under root 2 into 1 plus j. And if you take the magnitude, what you are getting? Array factor at theta equals to 180 degree. That would be 2 only. Look, you need to know complex variable. This is very simple thing. That's why I did this calculation very fast. E to the power j pi by 4 plus e to the power j pi by 4. So 2 into e to the power j pi by 4. So cos 45 plus j sin 45 and 2 into cos 45, that is 1 by under root 2 plus j sin 45, that is 1 by under root 2. So 2 into 1 by under root 2 plus j under root 2. What will be the magnitude of this? 2 only. Under root 2 square plus under root 2 square, that under root. So 2 plus 2, 4, 4 under root is 2 only. So what is the value you are getting? So at 180 degree, you are ending at 2 only. At 180 degree, you are ending at 2 only. So this point is 2, right? So this point is not alpha, this is ending at 2. So certainly these both guys are ending together. Now what do I need to find? I need to find the common area. So is this common? Yes. Is this common? Yes. What else is common? This is common, right? This complete part is common. So how will the final radiation pattern will look like? So final radiation pattern, from here if I draw the final radiation pattern, so that would look something like this. This is the radiation pattern for antenna array. So one lobe like this here, another lobe like this here, and then downward there is a circle. Downward there is a circle. This is how the final radiation pattern looks like. This is your theta equals to 0 degree. This is 90 degree. And this is 180 degree. Now I hope you must have had enough practice that how to draw these kind of radiation pattern. Let's solve the gate PYQs now. So in gate PYQs, this has been asked, okay, and this also has been asked. Both of the cases have been asked, and these are very standard and very famous. So let's start with this question. A lambda by 2 dipole is kept. Okay, let me take a break. You try it on your own. I guess you would be able to do it. We have already done it. Okay, so you would be able to do it. Just see here. Okay, so try doing it, and I will come back after a break, and you should be done with this. Yeah, so did you guys try this question? What they are saying, a lambda by 2 dipole antenna is kept horizontally at a height of lambda naught by 2 from a perfect conducting infinite ground plane. So there is a ground plane is there. This is the ground plane. From this above a height of lambda naught by 2, there is an antenna placed. This antenna is placed, which is lambda by 2 dipole antenna. This antenna is placed here. This antenna is lambda by 2 dipole antenna. Lambda by 2 dipole antenna. Any kind of antenna could be there, and it is placed above lambda naught by 2 height. Lambda naught by 2 height. So similarly downward as well, there will be current. Why is that so? Because this is a perfect conductor. This is a perfect conductor. So what I need to do? I need to take the mirror image. And if I take the mirror image, it will be taken right lambda naught by 2 distance. If it is above by lambda naught by 2, downward as well lambda naught by 2. And if this is having a current of I naught, if this is having a current of I naught, then this will have a current of I naught with a phase of pi. Why is that so? Because this is the current of I naught and this current would be opposite, right? Above the conducting plate, if there is a horizontal current, then that would be opposite. Radiation pattern you need to tell. So at a far point P, if I take any far point P, so at a far point P, the radiation will be because of both of the antenna, right? At a far point P, if I find the expression of electric field, so that will be there because of this antenna as well and because of this antenna as well, because of this antenna as well. Since this is a far point P, so all the lines will be parallel. So what we do, we assume a imaginary antenna at the origin and then we write down the electric field because of that single element at origin, and that single element is imaginary. So what will be my ESO? Do I need to write that down? No. What I need to make? I need to make the radiation pattern. So what I am gonna do? Only radiation pattern I am gonna draw. So for that, what I need to do? For that, I need to assume an antenna at the ground, at the conducting ground. So here I need to assume an antenna. Here. Now whether it is Z axis or Y axis, that we don't know, right? Whether it is Z axis or Y axis, that we don't know because it is not mentioned in the question. But when you see the options, here it is mentioned that this is your Z axis and this is your Y axis. Although it should have been mentioned in the examination, it should have been mentioned that which is your Z axis, which is your Y axis. But if you see the options, you can get to know about it. So this is your Z axis and this is my Y axis. Now you let me know one thing. What will be your angle theta here? What will be your polar angle? Polar angle is the angle measured from Z axis, and which is the Z axis? This is the Z axis. So angle measured from the Z axis, this will be the polar angle, right? This will be the polar angle theta and this will be the polar angle. What is the angle between arms of antenna and AR cap? Where is the AR cap? This is your AR cap, right? This is my AR cap. This is my AR cap. What is the angle between the arms of antenna and AR cap? That is theta only. So now we don't need to change the angle. 90 minus theta, that we don't need to do. Actually, this antenna is placed along Z axis only, right? If this is my Z axis, then antenna are placed like this. Antenna are placed along Z axis only, and it is placed on Y axis. Are you getting this point? Antennas are placed on Y axis and placed along Z axis. In all the previous diagrams, what was the scene here? That this was our Z, this was our Y, this is our X. So in those diagrams, antennas were placed on Z axis. Antennas were placed on Z axis, but it was placed along Y axis. But now what is the scene? Antennas are placed along Z axis, and on Y axis. Antennas are placed on Y axis and placed along Z axis. It is just the diagram is rotated. Are you able to visualize it? Diagram is simply rotated, nothing else. Because upward is Z, Y now. This is Y and this is Z. So now this is how we are showing it. This is how we are showing it. Are you getting this point? So theta is the angle, that is our polar angle. Polar angle is the angle measured from Z axis only. So this will be angle theta, this will be angle theta, and this will be angle theta. Yeah, now we were doing the radiation pattern because of the single element. So what we have done, we have assumed a single element at the origin. And if we have assumed the single element at the origin, so because of lambda by 2 dipole, which dipole? Lambda by 2 dipole antenna. Because of lambda by 2 dipole antenna, what kind of radiation pattern do you get? This kind of radiation pattern. If you remember it, I hope you remember it clearly. This kind of radiation pattern we get, right? And if I write down the F theta for it, so that F theta was cos pi by 2 cos theta divided by sin theta. This will be theta equals to 0 degree, and vertically this will be theta equals to 90 degree. This will be theta equals to 90 degree. And if you put cos 90 here, that would be 0. Cos 0 is 1. Sin 90 is 1. So it would be 1 only. So here you are getting 1 only. But I am not going to write down expression and anything. I will just draw the diagram. And why this is theta equals to 0 degree? Because this is your z axis. And why it is theta equals to 90 degree? Because this is your y axis. So this is how the radiation pattern of the single element will look like. And it is ending at 1. It is ending at 1. Now tell me one thing. Here there is ground, no? So when we were studying about the radiation pattern due to monopole, what we were doing? Here there is no concept of monopole and dipole. Here this antenna is dipole only. This antenna is dipole only. But when we were studying the radiation pattern because of monopole, what did I say? That radiation pattern you will get from in this much range only. Downward there is ground, no? After ground there is no radiation pattern. So this pattern I will remove. Why is that so? Because this is your ground. This is my ground. So this radiation pattern will be gone. This downward radiation pattern will be gone. So this is the final radiation pattern. Are you getting this point? So there is no doubt in the radiation pattern of our electric field because of the single element at the origin. Now we will draw the radiation pattern of array factor. So first we need to find out the array factor. So let's start. If this was having the current I naught, if this element was having the current I naught, so this is also having the current I naught only. So same phase, e to the power j0, then e to the power j beta. Now let's check out. So from the origin towards the antenna, this will be my, from the origin towards the antenna, this will be my d vector. So that vector is lambda naught by 2, lambda naught by 2. And what is the angle between lambda naught by 2 and AR cap? What I need to find? I need to find lambda naught by 2, whatever the vector is there, AD cap I am calling it, dot AR cap. This is what I need to find, right? If you remember, beta D1 dot AR. So what is the angle between them? 90 minus theta, right? The angle between them is 90 minus theta. So what is cos 90 minus theta? That is sin theta. So let's write it down. So beta lambda naught by 2 cos 90 minus theta, because the angle between them is 90 minus theta, plus what about the downward? What about the downward? So what I need to do? Going down, what is the distance? Lambda naught by 2. Here the phase is also pi. The distance is lambda naught by 2. And what is the angle between AR cap and lambda naught by AR cap and this vector? What is the angle between both of them? The angle is 90 plus theta. What is the angle? The angle is 90 plus theta. So let me make it in a better manner. The angle between both of them is 90 plus theta. You need to use a very good geometry. It is not that tough. If you are able to, you should be able to solve these kind of problems. But if you have seen it, and if you go with a good mindset, usually people don't solve this problem in these manner. If you have studied from someone else, you would realize they will make some formula, then they will put theta minus 90, 90 minus theta. It is hell lot of confusion. Just forget about it. Just solve by the geometry, because in the examination, standard question will not come. And if standard is not coming, then you will do some mistake. But if you solve by the geometry, if you solve in the manner that I am telling, that this is how you write down array factor, then you find the position of nulls, maxima and half power, then there is no chance of error and certainly you will get it correct. Array factor becomes, this antenna array becomes very typical topic for the students, but if they don't study it in a good manner. But right now we are giving everything towards this particular topic, right? So angle is cos 90 plus theta. There you go. So this is e to the power 0, that is 1 only, e to the power j. What is beta lambda naught? 2 pi, right? Beta into lambda naught is equals to 2 pi. So 2 pi by 2 is, 2 pi by 2 is pi. Cos 90 minus theta is sin theta, plus e to the power j pi, e to the power j, this will be pi. Cos 90 plus theta is minus sin theta. Okay. Now if I find the phase, difference, so phase difference would be from anywhere you can find. I am finding from here to here. So that would be 2 pi sin theta minus pi. Pi sin theta minus pi plus pi sin theta. So that would be 2 pi sin theta minus pi. Now if I need maxima, so for maxima, what is the condition? That phi should be equals to 2n pi. So 2 pi sin theta minus pi should be equals to 2n pi. So from here 2 pi sin theta is equals to 2n plus 1 pi. Pi and pi is getting cancelled and needlessly I am carrying it. So from here what we what we see is that sin theta is equals to 2n plus 1 divided by 2. Okay. If you put n equals to 0, what you are getting? Sin theta is equals to 1 by 2. If you put n equals to 1, that will not be acceptable because this will be 3 by 2. And if you put n equals to minus 1, what that would be? Minus 1 by 2. But will that be applicable? That will also not be applicable because what is the graph of sine? This is the graph of sine. So if you are getting negative value, that means you are going above 180 degree because what is the range of theta? Range of theta is from 0 to 180 degree only. And in case of sine, if you are getting the negative value, that means you are going above 180 degree. So this also we will not take. We will only we will only take this one. So theta is equals to. So from here two values of theta we will get because what is the graph of sine theta? This is the graph of sine theta 1 by 2. So 1 by 2 you will have at 30 degree and at 150 degree. So theta is at 30 degree and 150 degree. So this is the location of maxima because sine 180 minus theta is equals to sine theta only, right? What about the nulls? Let's say move it off. What about the nulls now? So for nulls, what is the scene? 2 pi sine theta minus pi should be equals to 2n plus 1 pi, right? So pi and pi is getting cancelled. So sine theta is equals to 2n plus 2 divided by 2. So that would be n plus 1. Sine theta is equals to n plus 1. Did I do it correctly? Pi and pi is getting cancelled. This would be 1, 2n plus 2. And then this will also cancel 2n plus 2 divided by 2. So pi equals to 1. N equals to 0. If you put n equals to 0, so sine theta would be equals to 1. So what you are getting? Theta equals to 90 degree. Right? This is one of the null. And if you put n equals to minus 1, that also will be applicable because sine theta would be equals to 0. If you put n equals to minus 1, so sine theta would be equals to 0, and that is 0 at 0 degree and 180 degree. So you are having nulls at 0 degree, at pi by 2 and at 180 degree. Now I don't think you need half power. Do you need half power here? I don't think you need half power because without even using half power as well, you can draw the radiation pattern now because you are having enough data 0 degree, 30 degree, 150 degree, pi by 2, 180 degree. You can make the radiation pattern, right? So forget about half power. So if I do the radiation pattern of what? This radiation pattern I am drawing for array factor. Okay. Why I am not making downward? Because downward there is ground. So what is this? Theta equals to 0 degree. Why this is theta equals to 0 degree? Because this is z axis. And what is this? Theta equals to 90 degree. Why is that so? Because this is your y axis. Answer me smartly what this would be. Theta equals to 180 degree. Right? Why 180 degree? Because from z you are measuring the angle, no? Previously what we were doing, theta equals to 0 degree, theta equals to 90 degree, theta equals to 180 degree. Because from z we are going towards 180 degree. If plus z is 0 degree, then minus z is 180 degree. So if plus z is 0 degree, then minus z is 180 degree. Right? Okay. Yeah. So now what's the scene? So nulls at 0 degree you are having 0 value. At pi by at 30 degree you are having the maxima. Here you are having the maxima. Then at 90 degree again you are having the 0. At 180 degree you are having the 0 and in between you are having the maxima. So here you are having the maxima. So I guess you are able to visualize this kind of radiation pattern you will get. Say yes or no. So this is the radiation pattern and this is the radiation pattern of the this lambda by 2 dipole. Now in the examination if I don't think much, so what I will be thinking that sir, this is the radiation pattern of array factor I have got. and this is the radiation pattern of a single element I have got. This is the radiation pattern of single element, and this is the radiation pattern of a array factor. I will quickly click on this if I don't think much. But is that what you need to do? No. You need to find the common area, right? What you need to find? You need to find the common area. Like someone will make this one, and then he will make this one, then he will say, okay, 2 lobes and another lobe, without even thinking, like this is a blunder, this is a minor mistake. So these kind of minor mistake happen in the examination in quick manner, that these 2 lobes are and in between the lobe, so all added, and this is the answer. Like this is a very foolish mistake that you can do. And when I was a student and when I solved this question for the first time, this is how I solved it. Okay, so that's why I'm telling it. When I solved it for the first time, this is some GATE 2007 question, I guess. So yeah, but we need to find the common area. Okay, so how we will find the common area? So let's make both of them on one plane only. And here in downward as well, the same kind of pattern will come. Downward as well, the same kind of pattern will come, but that we are not making. Why is that so? Why we are not making the downward one? Because that is of no use for us, because there is ground, right? So let's make both of them. So first I am making for lambda by 2. And then I will make for this is my array factor. What is this? This is due to single element, and this is array factor. And what is the common area? This is the common area. Like look, what some student can have the doubt there, sir, that sir, this was the radiation pattern of the single element, right? And this was the radiation pattern of the array factor. So sir, now what may happen is that this is how it can go. No, this is how it will not go. Why is that so? Because this guy is having nulls at theta equals to 0 degree. At theta equals to 0 degree. So certainly at theta equals to 30 degree, it would be having something, no? This would be its theta equals to 30 degree. What I am saying is that this ESO, this is having nulls at theta equals to 0 degree only. That means it is not having anything at theta equals to 0 degree. That means at theta equals to 1 degree as well, it will have something. Are you getting this point? If you have drawn the pattern of ESEO, so here you know that it will have nulls at theta equals to 0 degree. So at theta equals to 1 degree as well, it will have something. At 2 degree as well, it will have something. That means some radiation pattern would be there. And what about this case? It is having nulls at theta 0, 90 and 180. That means at rest of the points, it will have something. That's for sure. So at 1 degree, this guy is also having something. At 1 degree, this guy is also having something. That means certainly there will be some common area. Did you understand this point? Like this kind of structure will not come. Here, what is the common area? Here common area is 0. Because this is another area, this is another area, and this is another area. So here common area is 0. But this will not occur. And why this will not occur? Because at 1 degree, both of the component will have something. At 1 degree, this guy will also have something, and this guy will also have something. So certainly there will be some area. Right? So certainly if this is the area, then if you need to get out from here, then this is how it will look like. Like this is the common area. You see, if you see closely, this is the common area. Right? So this is the final output. Okay. So this is for the antenna array. And being this is your z-axis, this is your y-axis. So this is the final answer. It is not that tough. It is very easy. But if you mug up the formulas, then it will become very tough. If you solve by the problems, if you solve by the problem solving skills, it will be very, very easy for you. Say yes or no. Do you agree to this point? Do you find this? Are you enjoying these kind of lectures? Certainly you are enjoying. Okay. Certainly we are going to cover all these subjects in this manner only. This is not just about antenna or EMFT. If you see the analog, like you will fall in love with analog. If you see network analysis, you will fall in love with network analysis. If you see digital electronics, you will fall in love with that. Okay, this is just a self praise, but I should not praise my content. You should praise the content. But when you are seeing the content, you are realizing what kind of content we are delivering, right? So there is chance that like 99.99% chances are there that if the question is framed on antenna, then it will be framed till this topic only. If the question is coming from antenna, then from lecture 1 to this lecture till this point, question will be framed till this point only. But certainly there is one more topic that is known as n element antenna array. So now we are going to see the n elements. So this topic also we are going to cover. Okay, but in last 20 years, if you see, there is no question from this particular topic. This is very easy. Like there is nothing. It is very straightforward. Within 30 to 40 minutes, we will be able to complete it. But what I am saying is that mostly chances are there that the question will be framed from these topics only, and this is how you will be required to do the analysis. Rather than mugging up the formula, you will do the analysis in the examination. So let's cover n element antenna array. But before that, let's see a concept of antenna axis. So along which axis antennas are placed? Here, what I will say, antennas are placed along y-axis, right? Along y-axis. But antennas are placed on z-axis, right? On z-axis along y-axis. So what is known as axis of antenna array? Z-axis will be known as axis of antenna array. So what is the axis of antenna array? That is known as z-axis. Okay. That means the axis on which the antennas are placed, that is known as axis of antenna array. So this is your axis of antenna array. In the examination, if these kind of questions are written, that this kind of statement can come, that on the axis of antenna array. So what do you mean by axis of antenna array? That means on the axis where antennas are placed. Antennas could be placed along z-axis. Antennas could be placed along y-axis as well. It could be placed along x-axis as well. But if I am saying that my axis of antenna is z-axis, what does that mean? That all the antennas are placed on z-axis. On and along, two different words are there. All the antennas are placed on z-axis. What does that mean? If all the antennas are placed on z-axis, that means antennas are placed on z-axis only. That's it. This is the mean. So what is the antenna? What is the axis of antenna array? Here in this diagram, axis of antenna array here is, because antennas are placed on y-axis, along z-axis, on y-axis. So axis of antenna array here is y-axis. Okay. So on which axis antennas are placed, that is known as your axis of antenna array, right? So now n element linear antenna array we need to study. That means here, if this is the current I node, so this will have current I node, but phase shifted by alpha. This is this is phase shifted by 2 alpha. Next will be phase shifted by 3 alpha. How many elements are there? N elements are there. So nth element will be shifted by n minus 1 alpha. So there is uniform phase shift. 0, alpha, 2 alpha, 3 alpha, 4 alpha. So there is uniform phase shift. And spacing is also uniform. D difference, and in that manner difference will be D only. Here the spacing is D. This spacing is also D. So this D will keep on going. And if I ask you what is the length of this antenna array? What is the length of this antenna array in terms of, what is the length of this antenna array in terms of n and d? So can I write down the length as n minus 1 into d? If the elements are 2, so 2 minus 1 into d. So the length of antenna array is 2. If the elements are, if let's just say if n is equals to 3. So if I put n equals to 3, that means the length should be 2d. Yes, length is 2d. So if I put n equals to 10, then complete length is 9d. Say yes or no. Are you getting this point? So complete length here is 9 minus 1 into d. Did you understand this point? All the antennas are placed along z axis. Wait a second. Yeah, so what I was discussing that all the antennas are placed along z axis. Sorry, all the antennas are placed on z axis and along y axis. So if I ask you what is the axis of antenna array? Axis of antenna array. Antenna array. That is z axis. Right? Axis of antenna array is z axis. What is the length of antenna array? N minus 1 into d. Length of antenna array is n minus 1 into d. Okay, all the antennas are having I naught current spaced by d. All are phase shifted by alpha. 0, alpha, 2 alpha, 3 alpha, 4 alpha, 5 alpha till this point n minus 1 alpha. All are phase shift, all are having the spacing of d. Now what is the angle between the arms of antenna and AR cap? What will be your AR cap? Here will be the some point P. So this is your AR cap, right? All these are AR cap. This is AR cap. This is AR cap. This is also AR cap because all are parallel, so all are having the same direction. So all these are AR cap. So all these are AR cap. All these are AR cap. So what is the angle between the arms of antenna and AR cap? That is your 90 minus theta. Why 90 minus theta? Because angle made from z axis is theta. This angle is theta. This angle is theta. And this angle is theta. So this angle is 90 minus theta. Now I need to write down the electric field at point P. What is the way of writing it? What is the way of writing it? Electric field at point P. Electric field at point P. That would be electric field due to single element at origin. So that I am not writing down. Electric field due to single element at origin. That I am not writing down. Now my target is to write down the array factor. So how will I write down the array factor? What about the first one? What I will do? I will ignore all the antenna and I have assumed one antenna at the origin. Now with respect to that, how much phase shift it is having? 0 degree phase shift. So first current is having 0 degree phase shift. Then e to the power j beta. From the origin, the first element is how much far? 0. From the origin, the first element is far 0 distance. So here beta into 0 plus e to the power j. What about the second element? This second element is having a current which is phase shifted by alpha. E to the power j beta. Then what I need to do? From the origin towards the antenna. From the origin towards the antenna. This is the vector. And what is the angle between this what is the angle between this d vector and AR cap? That is theta. So what I am going to write down? D cos theta. Right? D cos theta because the angle is theta. Now what about the second one? What about the second one? E to the power j. How much phase shift is there? 2 alpha. So e to the power j 2 alpha. E to the power j beta. What is the distance from the origin? From the origin towards the antenna. The distance is 2d. And what is the angle between 2d cap and AR cap? The angle is theta only. What is the angle between this vector and this vector? That is theta only, no? All the angles are theta. If you find out the angle between this vector and this vector, this is the vector and this is the vector. So both vectors are in the same direction. So what is the angle? Theta degree angle only, no? Very simple. So angle is always theta degree. So beta 2d cos theta. Why 2d? Because from the origin the distance is 2d. Then from the origin distance will be 3d. Then from the origin distance will be 4d, 5d, 6d. And angle will always be theta, theta, theta. Say yes or no? So this is how it will go. In the last, what will come? Look, for the element at origin, 0 was coming. For the second element, alpha is coming. For the third element, 2 alpha is coming. So for the nth element, n minus alpha will come. E to the power j beta. E to the power j beta. This was for the second element. This is for the third element. So for the third element, 2 is coming. So for the nth element, n minus 1 d cos theta. Say yes or no? Right? Now what I am saying, I am putting alpha plus beta d cos theta as psi, or you can say phi or psi, whatever you can call it. So what you are getting, electric field at point P, that would be due to single element at origin 1 plus e to the power j alpha plus beta d cos theta. Here what you are having, alpha plus beta d cos theta, and that is written as e to the power j psi plus e to the power j 2 alpha plus 2 beta d cos theta, 2 alpha plus 2 beta d cos theta. So 2 alpha plus beta d cos theta. Here what is the phase? 2 alpha plus 2 beta d cos theta. So 2 I can take common, alpha plus beta d cos theta. What is that? Psi only. So 2 sine. Then in that manner, this will come. Let's write it down in a better manner. 2 sine. Then it will keep on going till the last what will come? N minus 1 sine. Okay. So what you are getting? Single element at origin. Now 1 plus e to the power x plus e to the power 2x plus in that manner we are going. Right? How many terms are there? E to the power n minus 1x. What is your x here? X is j psi. So what will be the summation of this? This is a GP. A into 1 minus r. What is the value of r? E to the power x upon r a into 1 minus r to the power n divided by 1 minus r. So r to the power n, that is nx, divided by 1 minus r, that is e to the power x. So what I will get here? A is 1. My first element is 1. 1 minus r to the power n. What is the r? R to the power n upon r minus 1 minus r. What is r? E to the power psi. Look, this is simple mathematics only. No one will ask you this question in the examination. That I can certainly tell you. Okay, no one is going to ask you. But still, it is mentioned. Like everyone teaches it, so we need to teach it. But in the examination, they will ask you these kind of derivation kind of purpose. Like a non-standard circuit, they will give you. Right? But this is a very standard circuit. Like you need to have the same current. Phase shift also is uniform. The difference between the length of the difference between the antennas is also uniform. So everything is uniform. This is very standard expression that we are going to get. But that expression is standard. It is mentioned in the textbook as well. That's why we are solving it. Okay. So what we are getting here, ESEO is from here, like what is the array factor you are getting, because important point is array factor here. So what is the array factor if we are getting? If someone asks you what is the array factor, so answer would be, this is my array factor. This is the array factor. Okay. How I can break it down? First thing is, this is the array factor. If someone asks you array factor for n element antenna array, this would be the array factor. How I can break it down? So what I can do is that I can take common as a to the power n psi by 2. This I can take common. Right? Yes. So what I am left with, e to the power minus j n psi by 2 minus e to the power j n psi by 2 divided by e to the power j. Are you understanding why I am doing so? Because I need to make the sinusoid expression. That's why I am doing so. Then you are left with e to the power minus j psi by 2 minus e to the power j psi by 2. Now if I divide by 2j, and take minus outward as well. What I am saying is that can I take minus common from here? I am taking minus common from the denominator. So if I take minus common, what will happen? Here minus sign would come. If I take minus common from the upward side, what will happen? What I am saying, I am taking minus common. So what will happen? Both will interchange their position and minus will come outward. E to the power j theta, e to the power j minus theta, e to the power j theta, and divided by e to the power j minus j alpha divided by e to the power j alpha. If I take minus common, what will happen? E to the power j theta minus e to the power minus j theta and minus sign. And from downward as well, e to the power j alpha minus e to the power minus j alpha, minus sign. Minus minus is getting cancelled. So e to the power j theta minus e to the power minus j theta, e to the power j alpha minus e to the power minus j alpha. This is the same thing I have written here. And now what I am going to do, in the numerator and denominator, I am going to divide by 2j divided by 2j. So this will also become a sinusoid function, and this will also become a sinusoid function, because I know that sin theta is equals to e to the power j theta minus e to the power minus j theta divided by 2j. So what I am left with, and minus will certainly get cancelled. So what I am getting, array factor is equals to e to the power j. If this goes upward, so what we are getting, n minus 1 psi by 2 e to the power j n minus 1 psi by 2. Okay, and here sine n psi by 2 divided by sine psi by 2. So this is the array factor, this is the another formula. But if I talk about the magnitude, if I talk about the magnitude of array factor, so what I am getting, what will be the magnitude of this one? 1. What will be the magnitude of this? E to the power j theta, that would be 1. So if I talk about the magnitude, then this is the magnitude I am getting. Now this is what people remember. They say that, sir, this is the array factor. They will say that, sir, this is your array factor. This is not the array factor. This is the magnitude of array factor. This is your array factor. This is the magnitude of array factor. Magnitude of array factor. Right? Both are two different things. अरे यार क्या बात है? Look, some guy sent so many photos. I don't know what he wants. Just let me pause the video. Yeah, so this is our magnitude of array factor. So this is not our array factor. Our array factor is this one. This is our array factor. This is just the magnitude of array factor. Okay. Yeah. So this I have written on the next page. The magnitude of array factor is this one. Now we need to find the maximum value of array factor. So let's remove this here, because here only I can find the maximum. Now what we are going to find? We are going to find the maximum value of array factor. What will be the maximum value at what value of phi it will occur? This is what we need to find out, because this is a strange kind of expression. No, this is not a sinc function. What is a sinc function? If you have studied the signal system, then sinc function is this one, sin x by x. So this is a strange kind of function. We need to find the maximum value of array factor. So what will be the maximum value of array factor, and at what value of phase difference, at what value of phi your maximum value of array factor will occur? This is also we need to find. So what we need to do? We need to differentiate with respect to phi. So d by d phi of array factor magnitude. This is what I need to differentiate, and we'll put that equals to 0. From there I can get the value of phi, and when I put that value of phi here, and at that time when I put the value of phi here, then I will get the maximum value, and whatever the value of phi I get, that would be the value of phi at which your maxima is occurring, right? So what we need to find? We need to find the value of phi at which maxima is occurring, and at that value of phi, what is the value of array factor? This is what we need to find. Okay, so what we are finding? Value of phi for maxima. This is what we need to find, and along with that we need to find the maximum value of array factor. So for that we are differentiating and putting that equals to 0. So can you differentiate? U by v I need to put u by v. So what will be my u by v? So this will be squared here, sine square phi, then this would come upward, then you need to differentiate sine and phi. So simple differentiation I am doing. So let's do it on next page. So sine phi by 2 will come upward, sine phi by 2 will come upward, then differentiation of sine n phi by 2, that would be sine n phi by 2 into n by 2 minus sine n phi by 2 as it is into sine phi by 2 and 1 by 2 here, divided by sine square phi by 2, and that would be equals to 0. From here what you are getting? N sine phi by 2 is equals to sine n phi by 2. Oh, sorry. Differentiation here it would be cos, no? That's what I was thinking. Differentiation of sine is cos, right? So here it would be cos. And here this is sine as it is, and this would be cos. Big blunder, right? So this would be cos. This 2 and 2 is gone, this sine square phi is gone. So here n is there, sine n phi by 2 cos phi by 2. Now you let me know one thing. For x tending to 0, what will be your sin x and what will be your cos x? For x tending to 0. If x is very small, then sin x is equals to x. And if x is very small, then cos x is equals to 1. If you have studied this in mathematics, if x is very small, then sin x is equals to 1 and cos x is equals to, sorry, sin x is equals to x and cos x is equals to 1. So here if I say that my phi is tending towards 0. Now I cannot solve this equation, right? I cannot solve this equation. Can you solve this equation? If you solve this equation, what you are getting? Here you will be getting a term of 10 and again you are getting a term of 10. So what you are left with? N into 10 phi by 2 into 10 n phi by 2 is equals to 1. This is what you are getting. Then how will you solve next? So what I am doing is that I am saying that if my phi is tending towards 0, if my phi is very small, then what will happen? This sin phi by 2 will be replaced with phi by 2 only. This cos n phi by 2 will be replaced with 1. This sin n phi by 2 will be replaced with n phi by 2. And this cos phi by 2 will be replaced with 1. Both are equal. What does that mean? That my phi should tend to 0. Hit and trial we are using. What we are using? We are using hit and trial. What did I say? If my phi tends towards 0, if my phi is very small, that means alpha plus beta d cos theta is very small, then this will be replaced by phi by 2, this will be replaced by 1, this will be replaced by n phi by 2 and this will be replaced by 1. Both are becoming equal. Both are becoming equal. Equation is satisfied. That means what does that mean? That phi should tend to 0. For maxima, your phi should be tending towards 0. And in the worst case, what I am going to put? I am going to put phi equals to 0. Or you can say phi equals to 0 for the maxima. For maximum radiation. So this is a very important point that we have got. So this is something that can be asked in your examination. That alpha plus beta d cos theta, if that is equals to 0, if phase difference is 0, alpha plus beta d cos theta is equals to 0, at that time you will get the maximum radiation. And that is pretty obvious as well. Why is that so? Because if alpha plus beta d cos theta is 0, then what will happen here? E to the power j0. What will happen here? E to the power j0. So all the terms will become 1, no? 1 plus 1 plus 1 plus 1 plus 1. So all will be added. If let's just say first term is 1 and another term becomes j, another term becomes 1, then another terms become j. So what it will be equivalent? 2 plus 2j. So here the equivalent will be 2 under root 2, which is not that high. But if all terms become 1, 1 plus 1 plus 1 plus 1, then what will be the equivalent? 4, which is the highest one. So if alpha plus beta d cos theta is equals to 0, that means if psi is equals to 0, then our job is done. Right? This also you need to keep in mind, that alpha plus beta d cos theta is equals to psi. So if all these are 0, alpha plus beta d cos theta 0, 0, 0, 0, if all these are 0, then 1 plus 1 plus 1 plus 1 plus, in that manner all will be added. And if all these are added, then our job is done. Right? We will get the maxima. So this is the first thing that we have got to know. For maximum radiation, phi should be equals to 0. Now second thing, what will be your AF max? AF max. So AF max you are gonna get at phi equals to 0. So if you put phi equals to 0 here, what will happen? Sin 0 divided by sin 0. Sin 0 is 0, 0 by 0, indeterminate form. If I am putting phi equals to 0 here, then I am getting indeterminate form. So what I can do? Either I can differentiate, but forget about differentiating. What I can do is that, what we have studied, that maximum you will get for limit phi tending towards 0. Sin n phi by 2 divided by sin phi by 2. Now if phi is tending towards 0, then sin n phi by 2 can be replaced with n phi by 2 and sin phi by 2 can be replaced with phi by 2. So what is the value you are getting? N. So from here, what did you understand? The maximum value of array factor is n. Maximum value of array factor is n. So this is another point. Now there is another term. What is the another term? That is known as normalized value of array factor. Do I have the page? Okay, I have the page. So till this point, what did I get to know? For maximum radiation, your phi, that is alpha plus beta d cos theta, should be equals to 0, and AF max is equals to n. So these are the conclusion. Now there is another term that is known as normalized array factor. Okay, normalized array factor. So that is given as array factor normalized. Array factor normalized. So this is given as mode of array factor divided by mode of array factor divided by maximum value of array factor. So what is mode of array factor? That is sine n phi by 2 divided by sine phi by 2 and divided by n. So what you are getting? Sine n phi by 2 divided by n sine phi by 2. Okay, so this is your normalized array factor. So these are a few points which you can keep in mind if you want to keep in mind. So this is the summary only. This is something that you need to remember. These 2 points, that's it. And you need to remember the orientation as well. That this is how they were placed. Along z axis, theta, 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 in that manner they were placed. So this orientation also you need to remember. Is that clear to you? All good? So let's see the summary. So how will you write down the electric field? This is how you will write down the electric field. 1 plus e to the power j alpha plus beta d cos theta, 2 alpha 2 beta d cos theta. In that manner we will go. Then what we are considering? Phi as, or psi you can say, phi as you can say alpha plus beta d cos theta. What is this? This is a phase difference. Then how you are writing down the how you are writing down the magnitude of array factor? That is sine n phi by 2 divided by sine phi by 2, where you are getting the maxima occurs for phi equals to 0, where you are getting the maximum radiation for phi equals to 0, and what is the maximum value? That is equals to n. And what is the normalized value of array factor? Normalized value of array factor is what it is equals to. Rather than this formula, you just remember this thing, that it is equals to the mode of array factor divided by the maximum value of array factor. That's it. So what is mode of array factor? Sine n phi by 2 divided by sine phi by 2 divided by n. So this is what you are going to get. So this is the summary of everything that we have studied in antenna array. That's it. This is the summary. Now there are two or three more points, like we need to study about broadside array and end fire array. So that we need to study about, but let me take a pause. Okay, in between let me take a pause. Then we will study about this broadside array and end fire array. Very simple point. In ECE it can be asked. So that's why we need to study about these 2 points. Yeah, so let's start studying about 2 kind of array. There are 2 kind of array. Basic definition can be asked in the examination. Statement wise question can come. And in ECE examination, some more question can come. So what kind of statement wise question can come, that we need to see. So there are 2 kind of array, broadside array and end fire array. So what do you mean by broadside array? So assuming that my antennas are placed on z axis, this is how my antennas are placed. Like there are n number of antennas that are placed on z axis. So what is my axis of array here? What is my array axis? My array axis is z axis. So in broadside array, I will get the maximum radiation normal to the axis of array. That means I will get my maximum radiation at theta equals to 90 degree. So where I am getting the maximum radiation? Here I am getting the maximum radiation. Maximum radiation at theta equals to 90 degree. So at the normal of array of axis, I am getting my maximum radiation. You can see the diagram as well. So you will be remembering the diagram, that at z axis I will place my antenna. So my array axis is z axis. So at the 90 degree angle, I am getting my maximum radiation. Say yes or no? All clear? Now this is an important point. So for maximum radiation, what should be the condition? Psi should be equals to 0. That means alpha plus beta d cos theta should be equals to 0. But here where you are getting the maximum radiation? At theta equals to 90 degree. You are getting the maximum radiation at theta equals to 90 degree. So I will put theta equals to 90 degree here. What I am getting? Cos 90 is 0. So that means alpha is equals to 0. What does that mean? That here my currents were, this was here at the origin, the current was I naught simple I0 current was there. Then there was a phase difference of alpha. Here there was a phase difference of 2 alpha. Now alpha should be 0. That means all the current should be in the phase. That means for broadside array. Now this kind of statement can come, that which of the statement is true. So for broadside array, the currents of all the antennas should be in phase. That all should have the same phase, because alpha is 0. Say yes or no. The phase difference between the currents should be 0. Say yes or no. All good. So this is about our broadside array. Now let's talk about end fire array. So for broadside array we will discuss one more point, but later on. First let's just discuss about end fire array, then we will see another point about broadside array as well. So one more point we need to see. Now for end fire array, again where I am assuming my antennas, I am assuming my antennas on Z axis only. But now the maximum radiation is on Z axis itself. Where is my maximum radiation? Here is my maximum radiation. So what is my array axis? Array axis is your Z axis. So what I have written, maximum radiation should be along the antenna array axis. So this is how my maximum radiation should be there. That means for maximum radiation, theta should be equals to 0 degree. And certainly psi should also be equals to 0. That means alpha plus beta d cos 0 degree should be equals to 0. What is cos 0? 1. That means alpha plus beta d should be equals to 0. So alpha should be equals to minus beta d. So if you need to design an end fire array, then the spacing should be minus beta d. Not spacing, sorry. Then the phase difference between the currents. If this is your I0 e to the power j alpha, then this would be I0 e to the power 2j alpha, I0 e to the power 3j alpha, I0 e to the power 4j alpha. So the phase difference between the current should be minus beta d. Is that okay for you? All good? So this kind of statement can come. So these are the two important points for your end fire array and broadside array. Very rare chance that question would be coming, but if that comes, you will be able to solve it. So what all are the important points? First point is this, that alpha should be equals to 0. Here alpha should be equals to minus beta d, and the maximum radiation at theta equals to 90 degree, maximum radiation at theta equals to 0 degree. So these are the two important points. Now these are the formulas, that what will be the directivity. What is this? This is the formula of directivity. So if you want to remember, you can remember. But in GATE, I am saying that there is 0.001% chance that this formula based question will come. These kind of formula based question has been asked previously, like in 90s in GATE examination. But if you see last 20 years of question paper, they never asked formula on directivity, half power beam width and first null beam width for broadside array or end fire array. Because these are just the formula, you need to remember it. If you want to remember it, you can remember it. But I will say, if you don't have time, if you feel like that your memory is weak, then do not worry about it. Just remember one thing, that this is double of this. The directivity of end fire array, this is actually ordinary end fire array. I'm not going to teach in depth of all these things. It is known as ordinary end fire array. So the directivity of ordinary end fire array is double of broadside array. So what points you need to remember? In broadside array, alpha should be equals to 0. And maximum radiation will be occurring perpendicular to the axis of antenna array. And here in end fire array, the maximum radiation will be occurring on the axis of antenna array. Alpha should be equals to minus beta d. These 2 points you need to remember. If you want to remember that directivity is doubled, that also you can remember. And if you want to remember this formula of half power beam width, first null beam width, that also you can remember if you want to remember it. Now, like if you remember this one, then it will be very easy for you, because under root and then double, under root then doubled. This is how you can remember if you want to remember. Otherwise, not recommended. Okay. So these were my duty to write it down these formula, but in a longer run as well, I will also not be able to remember these kind of formulas in longer run. Like right now I see it, okay, I remember it, but in longer run we will forget it. So not very important, but yeah, in previous years it is asked. Okay. So let's see a very important point regarding broadside array. So forget about the broadside array anything. I am giving you just one simple question. There are 10 antennas placed along z axis placed along z axis, you need to find me the array factor. So for finding array factor, what we are going to do? You need to find the array factor, and spacing between them is uniform, that is lambda, and all are having the current which are phase shifted by alpha. So here the phase shift will be 9 alpha, right? Because for the third element it is 2 alpha, so for the 10th element it will be 9 alpha, and all are having all are spaced at a distance of lambda. So let's try it out. So for the first one, if I write down array factor, so for the first one there is no phase and the distance is also 0, beta 0 is difference, plus for the second one the phase is, what is the phase? The phase is alpha plus j beta, and this is the vector lambda, this is the d vector, and this is your AR vector. Where is my AR vector? I did not show the AR vector here. This is my AR vector. So this is my AR vector. This is my AR vector. What is the angle? Angle is theta. So what you are getting? Beta lambda cos theta. This is angle is also theta. So beta into lambda cos theta, because angle is theta. So beta into lambda cos theta plus e to the power j, e to the power j. What is the phase shift between the current? 2 alpha, and then beta. What is the distance now? 2 lambda. 2 lambda cos theta, right? 2 lambda cos theta. In that manner it will keep on going. Now this will become 1 plus e to the power j alpha. What is beta lambda? 2 pi. Beta lambda is 2 pi. So alpha plus 2 pi cos theta alpha value I will, okay, let's now what is given? It is given broadside array. So for broadside array, for broadside array, what is the scene for broadside array? That alpha should be equals to 0. So what I am going to put? Alpha equals to 0. So if I put alpha equals to 0, what I am getting? My array factor is coming out to be 1 plus e to the power j 2 pi cos theta plus e to the power, this is 0, so it will become 4 pi cos theta. In that manner it will keep on going. So e to the power j, here it would be 18 pi, because this is twice, then 9, yeah, 18 pi cos theta. That doesn't matter. Basically the thing is, this is how the array factor will look like. Are you able to understand this point? Alpha I am putting 0, because for broadside array alpha should be equals to 0. Beta lambda cos theta, what is the value of beta lambda? 2 pi. What is the value of 2 beta lambda? Beta lambda is 2 pi only, so it would be 4 pi. In that manner last one will be 18 pi, because how many terms are there? 10 terms are there. First one is starting with 1, then second is starting with 2, third is starting with 4, fourth will start with 6. In that manner ninth term, like this last term, will start with 18. Now the thing is, for broadside array, or forget about it, if I put theta equals to 0 degree, then what will be the value of array factor you will get? 1 plus, if you put cos 0, what is cos 0? Cos 0 is 1, e to the power j 2 pi, e to the power j 4 pi. In that manner till e to the power j 18 pi. So what is e to the power j 2 pi? 1. E to the power j 2 pi, e to the power j 2n pi is 1. So what you are getting? 1 plus 1 plus 1 plus 1 plus 1, that is 10. And this is your maximum radiation. So at theta equals to 0 degree, what you are getting? You are getting maximum radiation. Now let's check at theta equals to 90 degree. If theta equals to 90 degree. So array factor 1 plus e to the power j. What is cos 90? 0. Cos 90? 0. What is cos 90? Again 0. In that manner 0, 0, 0, 0, 0. So what you are getting? Again 10. What you are getting? Maximum radiation. So what did you take in action? You said that it is broadside array. That's why you took alpha equals to 0. You have said that it is broadside array. That's why you took alpha equals to 0. When I took alpha equals to 0, and then I checked at theta equals to 90 degree and at theta equals to 0 degree and at theta equals to 90 degree. At both of the points I am getting maxima. But for broadside array, where I should have got the maxima? At 90 degree only, no? But why I am getting at 0 degree? The reason is your spacing is the multiple of lambda. This is the reason. The spacing between the antenna is the multiple of lambda. If the spacing is multiple of lambda, then you will get the pattern like this, that here also you are getting the maximum at theta equals to 0 degree, and at theta equals to 90 degree also you get the maximum. Here also you are getting the maximum, and here also you are getting the maximum. So in broadside array, this is a very important point. Generally for broadside array, we avoid the spacing between antennas to be multiple of lambda. Because in broadside array, if we are designing broadside array, then our requirement is that we get the maximum power along 90 degree, not along 0 degree. So this is our requirement, and we are not able to fulfill the requirement. We are getting the maximum radiation along 0 degree as well. So we usually ignore that, we usually avoid taking the spacing between the antennas to be multiple of lambda. So these kind of statement wise question can come. And why is that so? I have proved it here. That when I took the spacing to be multiple of lambda, then what I am getting? This is the array factor I am getting. And in this array factor, if I put theta equals to 0 degree and if I put theta equals to 90 degree, in both of the cases I am getting the maximum radiation. But I should have got, for broadside array, I should have got the maximum radiation at theta equals to 90 degree only. Why I am getting here? So this is something I want to avoid. So if I want to avoid this, that means I need that spacing should not be a multiple of lambda. And also, what should be the condition? That alpha should be equals to 0. And that condition I have taken. That alpha should be equals to 0. That means all these currents should be in phase. Right? So eventually alpha is 0. Then this was also I naught. This was also I naught. And all these currents were I naught only. All these currents were I naught only. Is that clear? So regarding broadside array, what can come? That what should be the value of alpha? That means what should be the phases between the successive current? 0. What can come? Maximum radiation at theta equals to 90 degree. And spacing between the antenna should not be a multiple of lambda. These three statements can be written and they ask you whether it is true or false. This kind of question can come. So 1 mark question can be framed. That's why we have studied broadside array and fire array. This is a very vast topic, but certainly it is not for our gate examination. In gate examination, they are never going to ask any much deeper question from it. And if they ask, then you can drop it, right? That's the thing, right? Like no one will teach you a broadside array as well in complete gate field, because never question has been asked. But if they ask, then these kind of questions they can ask. From both broadside array and from end fire array, question certainly has been asked, but very basic. Like in 90s, I guess the question was asked on this formula in 90s. So formula based question will not come. If they feel like that we need to frame a question from these two topics, then I guess they will ask the value of alpha, maximum radiation, and this point they can ask. So these are the main points. Is that clear to you? All good. Now try solving this question. Use your whole brain. This was asked in ISRO 2021. This is ISRO. I should not say ISRO. Really sorry. This was asked in ISRO. Use your whole brain and answer this particular question. I know like most of you might not be able to solve it, but we will understand a lot of good points from here. So first first answer me this thing. These are your transmitting antenna or receiving antenna. By looking at the question, if you read the question, you let me know they are transmitting antenna or receiving antenna. The output of 3-element collinear antenna array operating in free space environment is combined after appropriate phase shifting to maximize the signal received from a particular direction as shown. Signal received. Signal received. So they are transmitting antenna or receiving antenna? They are receiving antenna. So they are receiving the signal. Now, if the inter-element spacing is half of the signal wavelength and direction of maxima response is 30 degree from the perpendicular to the array, then what are the phases to be applied to each element? Consider the first element as the reference. Luckily, in the examination, this option was not given. This option was not given. Luckily, in the examination. So, if all these 4 options are given, then this question is easy for you. If all these 4 options are given, then it would be easy. But this option was not given. But if gate frames this kind of question, then certainly they will give this option as well. Here, both of the phases are different. Look, minus 0 is equals to 0. Minus pi is equals to pi. What I could have done here is that I could have put minus pi here as well. Right? I could have put minus pi. But minus pi is equals to pi only. 0 is equals to minus 0. But minus pi by 2 and pi by 2 are different. So option E and C are different. So what would be the answer? Although this was not even given in the examination, that means answer would be C only. But let's talk about the difference between these two. But first, let's solve the problem. So I will copy this structure on the next page. Now here what they are saying, if the inter-element spacing is half of the signal wavelength and direction of maximum response is 30 degree from the perpendicular to the array. So how arrays are placed? Perpendicular to 30 degree from the perpendicular of array. 30 degree from the perpendicular of array. That means arrays are placed like this. Do you agree to this point? Arrays are placed like this. Because if you read this statement very carefully, what they are saying, the direction of maximum response is 30 degree from the perpendicular to the array. So certainly arrays would have been placed like this. This is how the arrays are placed. And what they are saying is that this angle is 30 degree. That means certainly this angle, this is your AR cap, right? This is your AR cap from where the received waves are coming. So that is your AR cap. This is your AR cap, right? If I talk about my AR cap, this will be my AR cap. If you see it clearly, these are the antennas. Forget about this block. I will talk about this block later on. But these are the antennas. These are the antennas. And at some point from very far point, let's take them downward. From very far point, from here, some rays would be coming. So for these antennas, this would be the AR cap. No, this would be the AR cap. This would be the AR cap. This would be the AR cap. So between the arms of antenna and AR cap, what is the angle? 60 degree. What is the angle? 60 degree. And what is the difference between them? Like what is the spacing? That is lambda by 2. Spacing is lambda by 2. Spacing is lambda by 2. So can I write down the array factor? Yes. How I can write down the array factor? So what they have said here is that consider the first element as reference. So this is the first element. You need to take this as a reference. So this is having I naught current. This is what I am saying. From the received signal, what is the job of receiving antenna? You will give it E and H, and it will give you V and I. And those V and I are given to these phase shifter, and finally we are having the output. This is what they are saying. So these receiving antenna have received some E and H. So it would have given us some I naught. This would have given us some I naught with the phase of alpha, and this would have given us some I naught with phase of alpha 2, alpha 1. Say yes or no? Agreed to this point? Certainly you are agreeing to this point. Now what is the array factor? So I am taking this as a reference. So this has 0 degree phase in the current, and from the origin the spacing is also 0, basically beta into 0. So this is my reference. Here what is the phase? Alpha 1, e to the power j, e to the power j. What is d? Lambda by 2. D dot AR. What you need to do? D dot AR. So lambda by 2 D dot AR. What is the angle? Cos 60. Are you getting this point? Why the angle is cos 60? Because this is my D. If you can show it clearly, this is my D vector, that is lambda by 2. And this is my AR vector. So angle is 60 degree. I hope you are able to visualize. So beta D cos 60 plus फिर टेढ़ा क्यों जा रहा है भाई? A to the power j alpha 2 e to the power j beta. Here what is the distance from origin? What is the distance? Lambda is the distance, lambda. And what is the angle? This is the vector and other vector is this one. What is the angle between them? 60 degree only. Again cos 60. Are you able to understand this point or not? Usually we get minus sign here, but now we are not getting the minus sign. You need to solve it using the geometry. From the origin, the distance is lambda, and this is the direction, and this is your AR cap. So what is the angle? 60 degree. So lambda cos 60. Say yes or no? If you solve it, what you are getting? Array factor is 1 plus e to the power j alpha 1. What is cos 60? Cos 60 is 1 by 2. Cos 60 is 1 by 2, that you already know. And what is beta lambda? Beta lambda is 2 pi. Beta into lambda is 2 pi. And cos 60 is 1 by 2. So 1 by 2 into 1 by 2, that would be 4. So what you are getting here? Plus pi by 2. Here beta lambda is 2 pi divided by 2 into cos 60 is 1 by 2. So what you are getting? Pi by 2. So e to the power j alpha 1 plus pi by 2 plus e to the power j alpha 2 plus what is beta lambda? That is 2 pi. What is cos 60? 1 by 2. So that is equals to pi. So this is the array factor we are getting. So what is the array factor we are getting? This is the array factor we are getting. Yeah, sorry for the interruption. So this is the array factor we got. Now listen to the statement very carefully. The most important line of this question is coming. In this question, there are two things. That this setup is done to receive the maximum power. What they are saying? To maximize the signal received. That means from P, if you need maximum signal to be received, then this is the setup that has been done. That means you need to place such that it is making an angle of 60 degree. Are you getting this point? From the P, what is this? This is the transmitter. So from P, if you need maximum E and H, from P, if you need maximum E and H, then this is the setup that you have done. That means here you are getting the maximum value of received signal. That means your array factor has to be maximum, no? Are you getting this point or not? The received signal is maximum. From point P, the setup is done in a manner that the received signal is maximum. What does that mean? If received signal is maximum, that means the array factor has to be maximum. So what do we need? If received signal strength by antenna array is maximum, then array factor should also be maximum, right? And you want array factor to be maximum, then what should happen? This is having a phase of 0. Alpha 1 plus pi by 2 should go to 0 and alpha 2 plus pi should go to 0. Because if e to the power j0, that would be 1, e to the power j0, that would also be 1. So this should go to 0. So alpha should be equals to minus pi by 2 and alpha 2 should be equals to minus pi. Luckily, this option was not given. 0 minus pi by 2 pi. If this was given, people would have clicked on this one. But that is wrong. Why that is wrong? Let me tell you. Answer is 0 pi by 2 pi. But what we are getting? Certainly, first one is having 0 phase. Then second one is having minus pi by 2 phase. And third one is having minus pi phase. If in the examination, if they ask the question like this, that what value, how much current will be flowing in the receiving antenna? From point P, some EM wave is coming, and because of that EM wave, because of that maximum EM wave, how much current will be flowing in the receiving antenna? What will be their respective phases? Then answer would have been 0, minus pi by 2 and minus pi. Their respective phases are 0, minus pi by 2 and minus pi. But this is not what they are asking in the examination. They are not asking you the phases of current. If they had asked the phases of current, then this would have been the answer. But what they are asking, see it very carefully. If the inter-element spacing is half of the wavelength and the direction of maximum is 30 degree from the perpendicular of array, then what are the phases to be applied to each element by this phase shifter? What does that mean? Now our setup is from that point P, we will receive some current. From that point P, E and H would come. From that point P, E and H would come. And because of that E and H, here I will have I naught current. Here I will have current I naught with the phase shift of minus pi by 2. And from this I will have a I naught current with phase shift of minus pi. Then what I'm going to do? I'm going to take out these currents. And I will apply it to a phase shifter. What this guy will do? This will just shift the phase. I will take out this current and I will apply this to a phase shifter. What this will do? This will just shift the phase. Same thing I will do here. And then finally what I will do is that I will do the summation. And here I will receive my final output. So what should be the final output? What should be the maximum final output? This output you will receive, but it should be maximum. Can you let me know what could be the maximum final output? The maximum final output would be that from here I naught is coming, and from here as well I naught is coming, and from here as well I naught is coming. So maximum possible output is I naught plus I naught plus I naught. So that would have been 3 I naught. From this one, if you need I naught, that means this phase shifter should give you 0 degree phase shift. From here, if you need I naught, that means this phase shifter should provide you pi by 2 phase shift. And if you need I naught from here, that means this phase shifter should provide you pi phase shift. So phase shifter should provide you 0 degree phase shift and pi by 2 phase shift and pi phase shift. If the question has been asked that what is the phases of the current because of this E and H, what is the phases of current, then the answer would have been 0, minus pi by 2 and minus pi. But what they are asking, they are asking the phases that needs to be applied by the phase shifter. So if I need the maximum current, that means I know if I need, then whatever the phase that they are already having, they are already having the phase of 0 degree, minus pi by 2 and minus pi. So this phase shifter 1 should provide 0 degree phase shift, phase shifter 2 should provide pi by 2 phase shift, and phase shifter 3 should provide pi phase shift. And if they provide pi shift, if they provide these phase shift, then the current would be I naught, and I naught, and maximum output you will receive will be 3 I naught. Say yes or no? So phase shifts of current, phase shifts of received currents, that is 0, minus pi by 2 and minus pi. But phase shifts to be provided by phase shifter, that would be 0, pi by 2 and pi. So that equivalent becomes 0. So if in the gate examination, if they want to frame a good question, then certainly they will frame these two options, this option and this option. E option also they will frame. And what I feel is that in the examination, they will ask you the phase shift of current. So if you don't read the question carefully, if you don't understand the meaning of question, then you will not be able to solve it. I hope the meaning of question is clear to you. What they are doing is that there are receiving antenna, and they have set up the receiving antenna in a manner that from point P you will have the maximum radiation. From point P, radiation is coming and you will get the maximum current. And if you need to get the maximum current, that means you need to have a phase shift of minus pi by 2 and minus pi. So alpha 1 has to be minus pi by 2 and alpha 2 has to be minus pi, because this phase shift is already coming. This phase shift is already coming. So alpha 1 has to be minus pi by 2 and alpha 2 has to be minus pi. Say yes or no? And now what will phase shifter do? Phase shifter will provide the opposite shift, so that from here I get I naught, from here I get I naught, and from here I get I naught. So total answer is 3 I naught. The best question of antenna till this date, this is the best question of antenna I have seen in any examination. Okay, and in nowhere, like I don't think any other coaching institute have made the solution. Only one coaching institute have made the solution, and that was also not correct. So nowhere the correct solution is also given. So this is the correct approach. This is the correct solution of that particular question. I hope you understood a lot of new points. I hope you enjoyed watching our antenna array, and I'm really sorry for the interruption that was there in between because of my throat. But I hope you enjoyed the lecture, and I hope you enjoyed complete EM wave lectures. Not only EM wave, complete electromagnetic field theory. So here our electromagnetic field theory ends, but certainly there are some miscellaneous topics like fiber optics is left. Fiber optics, that is very good topic. So that we are going to cover, and some miscellaneous topics are left, like what will be the power loss in waveguide, because in waveguide there are conducting plates, and the dielectric medium can also be lossy. So there would be power loss. So that power loss we need to discuss. And then one more topic is there, that is about reflection coefficient. So reflection coefficient in EM wave we have studied for two medium 1 and medium 2. So that reflection coefficient we have studied. But if there are 3 medium, or if there are 3 or more medium, then what kind of reflection coefficient you will get? So those points we need to discuss. So that is the one point we need to discuss. And then small points are there, like types of transmission line, like there are coaxial cable transmission line and there are 2-wire transmission line. So those are also 2 small points. So those points also we need to discuss. So small points are there. Like if you see on the top level, the syllabus is completed. Fiber optics is left, that also we will cover. But some small points are there which we need to cover. Okay. Okay then. Thank you very much. I hope you enjoyed it. And if you enjoyed it, I want your comments in the comment section, because like you would know what kind of understanding this requires. Right? Yeah. Thank you very much.